Hi, everyone. Welcome to COM 2026. Today, we're going to talk about the variable scope. This part will not appear in our MC questions quiz. Now, what is variable scope? Turns out variable scope is extremely useful in programming. Imagine a project is usually developed by multiple developers. These developers will contribute their codes and integrate together. Each code will work independently, but they are collaborating. Now, what if these code segments share the same variable names? It could bring out some risks that if these variables have the same name and these variables may interfere together if there is no such thing called a variable scope. A variable scope is to make sure there is a shield between different segments of codes that these variables does not interfere with each other. Okay? Most of our program, I should say all of our Java program has to be written inside a class. So inside a class, we could have a structure like these things. We could have some methods. One of the methods called the static void main. We usually see that, and we could have some non-static methods here. Well, so far we don't know what is static or not static mean, but just bear with me. We could have multiple different methods, and we could also have something called a member variables or field that declare in a class. So number one, this is the things that we call the member variables or field. This is one of the place that we can declare our variable. At this moment, the example that we have all presented does not have a member variable. Secondly, we could have something called a parameter. A parameter appears in methods or a function, if you want to call that. Okay. In Java, we call a function a method. So these parameter is part of our member uh, methods. Okay. And then we have something that we usually see in our previous example that will be our local variable. Okay. So these one are our member fields, member variables and fields. These a and this para x will be our parameter, and three, these things will be our local variables. Now, what does that mean by a scope of a variable? A scope of a variable means that the area that the variable is visible. Okay, and we will talk about that for each types of these variables. Where are their scopes? So the first one, the scope of member variables or field. Okay, so we declare the member variables or field in a class. Within the same class, these variables or fields is visible. So for instance, field X, field Y are visible within this curly bracket, which means here we can use field Y. From this method, main, we can use field Y. We can reuse the name field X in here when we declare the field Y as well. Secondly, we want to talk about the parameters. Parameters are with a method or function, if you are more familiar with these terms. Okay, in a method, we declare the parameters right after the method. So, for instance, this main is a method. Okay, this parameter is declared right after these method names with a parenthesis. The scope of this parameter param a is within the scope of the method, which means The method is defined from this curly bracket to this curly bracket. The scope of the parameter, param A, is defined within this bracket only. So for instance, this param A is not visible in the method here. Okay, method. All right, this is not visible. Now, what does that mean by it's not visible? Which means when you type param A inside this method, what will happen is the compiler will yell saying that param A is not understood. Okay, this variable is undefined. Similarly, param X is defined within the method here. So it is okay to refer param X within its method. However, if we try to refer param X in main method, this is invalid because simply param X is outside of its scope. The third one is local variable. A local variable is defined within its immediate parent curly bracket only. Now, so look at this local variable x. This is defined within its immediate parent, which is this curly bracket, which means this local x is visible within the entire method. How about this local y? Local y is defined within its immediate parent curly bracket, which is here. Okay, so within this curly bracket, you can refer local y. You can, of course, refer local x. Okay, and local x is accessible here, but local y is not accessible here because this is simply outside the scope of local y. All right. Outside this method, local x is also invisible. Now, let's look at a slightly more complicated example here. Local x is defined here, which means the entire method we can use the name of local x. Local y is defined within this curly bracket. Okay, so outside this local y, y is not visible anymore. The reference of local y here and here is acceptable. Local z is defined within the if block here. So in this else block, which is already end of the scope of local z, you can't refer local z here. Okay, this local z is undeclared variable, so we would be very confused. The program will not be able to compile. Now, in this block, we know local y has gone already. We can't, the visibility of local y has gone already, and it ends the scope of local y. But within this block, okay, we can, because the scope of local y is gone already, we can actually redeclare local y and make it as a new variable. So here, local y, we declare as an integer and assign it with a new value 5. Okay? So after this one, local x equals to local y. This is invalid because local y is only defined within the scope here, and this is invalid. Now, some rules about scope. First of all, the local variables and parameters are invisible outside their scopes. Reusing variable names outside the scope is allowed. The value of the variable will be lost when it is outside of its scope. When this is invisible, okay, when it's out of its scope, the original value will lost. So even if you reuse the variable names, okay, it does not retain the original values. Defining a local variable within the same scope of the variable names is not allowed, which means if two variables share an overlap scope, okay, two local variables with an overlap scope, that will not be allowed. Local variables or parameters will have a higher precedence than fields of a class. Now, what does that mean? We say defining local variables with the same variable names is not allowed. But actually, we can have a variable names same as the fields or the what we call the data member, okay, the member variables or the fields of a class can share the same name as the local variables or parameters. But when these two things happen at the same time, we will refer the local variable and parameters first. We'll talk about number 5 slightly later. Now, look at this example. Local x equals to 10 and local x larger than 10, and we define if local x, this one is invalid. Why? Because local x defined here has its scope in the entire map. When we declare a variable, local x, that is not acceptable. Similarly, if you say local x here, this is not acceptable because the scope of here and this one is overlapped. When you have a parameter x, you can't declare another local variable with the same name x. You can, however, name a local variable or parameter even if the name has been taken by a field. So look at this one. Let's say x is a field which is defined outside the method. Okay, within the class but outside the method. We have x here and we have x here which clash with the name x. This is acceptable. But when you use this x here, we will think that this x is actually referring to the parameter x. This is this x, not this x. Okay, this x and this x are not the same, although they share the same variables name, but this x will be actually the parameter. In the example below, we declare another local variable x, which has an overlap scope with the field x here. In this case, we will print the value x equals to 10, okay? Because this is simply, we will take a high precedence when we read the values. Now, if you want to refer to the field variable, you can use the keyword this to explicitly refer to a field. So for instance, if you have x here, you just say x, that print x. If you really want this one from the field, you can say system.out.println this.x. Then it will actually refer to this x. So this ends of our part about scope. In the next chapter, we will talk about simple I/O. See you later. Bye.